We are talking about investigation 1, the effect of bulbs in a series on current and voltage. Use a test circuit similar to this one, all right, to test your hypothesis and record your data in the table below. Use the boxes on the right to give the wires and battery a little resistance. Okay, so I first need to make a circuit that looks like this. So that's what I'm gonna do. I'm gonna get my battery, wire, switch, wire, I need an ammeter, wire, ammeter, wire, 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 light bulb, wire, and I'm gonna start with just one, okay? Now I need my voltmeter. I'm gonna set it up here and here. All right, I should have 0 volts because it's not turned on. So now I'm gonna turn it on. What voltage is your battery? I'm gonna turn off the current. What voltage is your battery? If you click on your battery, it should show your voltage, 9 volts. So that's gonna go right there, 9 volts, all right? Okay, now, what is the voltage when I'm just using one bulb? It's 9 volts, okay? And it should be 9 volts because my battery is putting out 9 volts. Bulb 1 is sharing none of this voltage with anybody else, okay? So bulb 1 is using 9 volts. Now let's look at our ammeter. Our current is 0.9 amps. Okay, our second ammeter is the same, 0.9 amps. All right, now let's add another bulb. I'm gonna cut this guy, move it over, put a light there. Okay, let's test one bulb. The voltage is 4.50. All right. 2 bulbs is 9. I'm just going to copy and paste that. All right. So now let me ask you this. How much voltage is our battery putting out? 9 volts. 9 divided by 2 is? So that means each bulb is using 4.5 volts. So if I have 4.5 volts for this bulb, 4.5 volts for this bulb, add them together, and that gives me 9 volts. Okay, 4.5 here, 4.5 here, all right? Our current is 0.45 on both of our ammeters. .45 amps, okay? Now we need a third light bulb. So I'm gonna cut this. All right, we have 3 light bulbs, 1 9-volt battery. Our amps, 0.3 on both of our ammeters. Okay, now let's check our voltage. 1 light bulb is giving us 3 volts. All right, 2 light bulbs is giving us 6 volts. Oop. What do you think 3 light bulbs is going to give us? 9 volts. Okay, so how many light bulbs do we have in this experiment? We have 3. A 9-volt battery divided by 3 light bulbs is 3 volts. Okay, so that's 3 volts each. Each light bulb is using 3 volts. All right, describe the relationship between the current and the number of bulbs in the series. Well, we have 1 bulb here. It's 0.9. As we add a bulb, we're saying, what's 0.9 divided by 2? 0.9 divided by 2 is 0.45. What's 0.9 divided by 3? It's 0.3. Okay, so as the number of bulbs increases, the amps they decrease. Describe the relationship between the voltages in the circuit and the number of bulbs. 1 bulb is using 9, when there's just 1 bulb, it's using 9 volts. As the number increases, the voltage goes down per bulb. Okay, so whenever one thing goes up and the other goes down, because the first one is going up, that is called an inverse relationship. Okay, write a conclusion of your investigation. All right, another one that we had trouble with in class was this one. All right, so let's look at this. This is an experiment, okay? A group of students conducted an experiment using resistors and a voltmeter, okay? I want to delete all of these. Okay, resistance with, they were provided a selection of resistors with resistances of 100 ohms, 220 ohms, and 300 ohms, okay? So I'm going to get one resistor out and I'm going to make sure it's the right amount. 100. So I'm going to slide this guy until it's at 100. Okay? 100 ohms. The other one is 220. All right? Well, this one only goes up to 120, so I'm going to have to delete it and I'm going to have to get a different resistor. All right. Woo, that's a lot. Slide it down until it's 220. Okay? And then the third one of 330. Okay. We have our 3 resistors and a 3-volt battery. So I'm going to go get me a battery. Okay, I'm going to put it right here. And I'm going to turn it down to 3 volts. Now, how much is a AA battery usually? If you were to Google this, a AA battery is usually 1.5 volts. So some people said that they thought it was 2 batteries because of the symbol. Well, it could be. AA batteries are usually 1.5 volts. So if we wanted 3 volts, then we could put 2 1.5 batteries together. But since this is a simulator, we can just make this one battery 3 volts. Okay. They were also provided with a resistor whose value was not known. So I'm just going to grab this guy. We don't know this guy's resistance. Okay. The resistors they were given were labeled as follows. A, B, C, D, E, F. Okay. X is the resistor with the unknown resistance. Below is their write-up. We set up the 4 circuits shown in the diagrams. For each circuit, we measured the voltage across the battery and the voltage across each resistor separately. Our results are shown below. Well, let's recreate this experiment, okay? We're going to need our wires. Ooh. Okay, we want resistor A connected to resistor B of the same amount. I don't know if we can duplicate, so I'm going to have to get another resistor, and I'm changing this to 100. Now look at the colors of the resistor as I change the amount. They also change. Okay, all right. Now I need my voltmeter. Okay, I am testing. We have 1.5 volts here, which is what we got for resistor A. All right, that's what they got, good. Now we're gonna test this one, 1.5 volts. Okay, so far so good. Now we are testing it with, A is gonna stay the same, okay? And then we're gonna use the D resistor, this guy right here. Okay, now 0.94 voltage here for A. All right, 2.06, so it's a little bit off. Theirs is a little bit off. You could change that though, okay? So we're gonna say 2.06. We're just gonna beep, beep, beep. Okay. Now, we want to test the next one, and that's with resistor F of 330 ohms. All right, total voltage is 3 volts. 0.7 for this guy right here for resistor A. Resistor F is 2.3, okay? So far, so good. All right, now we need to measure our unknown resistor. Okay, total volts is 3. Resistor A, well, we don't know what this resistor is, so we can't actually do that. I'm realizing. Okay, so what do you think Abby and Mark's research question was? Now, we're using the scientific method here, okay? The scientific method, make an observation, ask a question. What was Abby and Mark's research question? It may have been something along the lines of, how much resistance is resistor X? Okay, what was the independent variable? What is an independent variable? An independent variable is a variable that is changed or controlled in a science experiment to test the effects on the dependent variable. So what is changed or controlled? Resistor A is controlled, okay? The voltage changes. All right, we have to have a clear understanding before we can answer these questions between the independent and the dependent variable. And I have actually sent an email to Ms. Tolles, and we will see what the science teacher says, okay? All right, so what are the controlled variables? What sort of relationship does the data suggest? Well, we still don't know what resistor X is, do we? So what we're going to do, we're going to pull up a calculator, okay? If we have, let's see if I can also pull up a sticky. Okay, so on our sticky note, we're gonna do a little bit of math. Okay. We have resistor A of 100 ohms putting out 1.20 volts. So I'm going to say 1.20. All right, draw a line under here. It would look like this. Or let's see, like this. Okay, divided by 100 ohms equals 1.8 volts over X. So now we're going to cross multiply, and when we cross multiply, we are multiplying these together and multiplying these together. So 1.20 times X equals X. 100 times 1.8 equals 180. Right? We could have just moved the decimal over. All right, so now we have to divide both. We're solving for X. So we have to divide both sides by 120. Okay, so the left side divided by 1.20 cancels that out. And so we're saying 180 divided by 1.20. That gives us 150. So that tells us that the resistance for resistor X is 150. Now whenever we go in here, we should be able to, we can't use this one, we got to use a different resistor. Okay, we should be able to set this resistor to 150 and get the same numbers that our scientists got. Okay, so we're testing resistor A, and that's 1.20 volts. Good. Testing resistor X, and it's 1.8 volts. Okay, so we know 100% that resistor X is 150 ohms. Okay. Okay, so Ms. Tolles is saying that the controlled variables would be the 3-volt battery, the connecting wires, the 100 ohm resistor, and the digital voltmeter. Independent variables would be the additional resistors that are being changed, okay? The dependent variable would be the voltage that's being measured. And so that should help us with that. Okay, what sort of relationship does the data suggest? Now, if you notice something, when we add these together, how many volts are we getting? When we add these together, how many volts are we getting? And these, and these. Every single time we have 3 volts because that's how much our battery is putting out, okay? So as the resistance increases, our voltage increases. Our voltage for that resistor increases, okay? Can the resistance of resistor X be found from their investigation data? Well, we already found it, so yes. And if this was on paper, you could 100% work out that just like we did. And that's it.